Okay. Hi everyone. Good evening. Today's session we are going to discuss additional vSphere features. So today we are going to focus on resource pool and vApp. These two features we can cover. And before start the resource pool, we also need to learn some basics to understand the resource pool concept. So here is the agenda. And if you see the right side icon, the first icon refers as a resource pool icon, and the below icon refers as a vApp, vApp icon. And this is the agenda topics today. And first we can verify what is the virtual machine CPU and memory resource allocation settings. What are all the settings we have for a individual virtual machines? The resource allocation settings includes shares, limit, and reservations. Within this share and limit reservation we can discuss, and then we can try to understand the resource allocation shares overview and what is the scenarios available for the shares, and resource allocation settings at cluster level, how we can verify these resource settings under the cluster, and virtual infrastructure challenge and what is the solution. So what are all the challenges is resource pool is addressing, so the solution will be resource pool. Once we understand the resource pool solution concept, then we can verify resource pool architecture and identify the resource pool hierarchy and resource pool attributes. Attributes means features, and managing the virtual machines with vApp. vApp also almost similar to the resource pool concept, but in the vApp we have there is some additional features are involved in a vApp. So we can discuss about the vApp also. vApp is like a advanced concept of resource pool, and the resource pool use cases and vApp characteristics or features. And finally, we can do the home lab for both resource pool and vApp. Let's start with the first point. So virtual machine CPU and memory resource allocation settings. Normally, when you select your any of the vCenter level, when you select any production virtual machines, right click the virtual machine, go to the edit settings. Suppose in our lab, one of the VM is VRA VM, vRealize Automation 01 VM. I just select the VM and edit settings. You can find the virtual machine edit settings, VM hardware tab, virtual hardware tab. We have a CPU section and as well as memory section. If you expand the CPU section, you can see there's some multiple options. Here the options are cores per socket, how many sockets are there, and we have a 12 CPU and socket is one socket. And CPU hot plug, we are aware of hot plug feature. And now this is the time to discuss the some resource allocation settings today. So resource allocation settings, the main three settings are available: reservation, limit, and shares. The same resource allocation settings available for memory also. Even if we expand the memory, you can see same kind of resource allocation settings: reservation, limit, and share. But only difference here is for CPU, the resource allocation settings units are measured in a megahertz, gigahertz, and so on. Suppose in the memory also, the units are different, but the concept almost similar. In the memory, settings are same, but the units are like a megabyte, MB, GB, terabyte, and so on. So megabyte, GB, any units you can use, but the concept is almost similar to the CPU and memory. And when available resources capacity does not meet the demands of the resource consumers or customer, we might need to customize the amount of resources that are allocated to VMs. That means, suppose some customers, they want to dedicate a CPU and memory, they want to reserve the certain amount of CPU, certain amount of the memory. If you want to reserve at the VM level, the reservation option is just VM edit settings. You can reserve your values. So how we can edit is just log into our lab system. We can just verify the option. Suppose I'm connecting to the our ESXi host. Even if you connect to direct ESX host and vCenter, the options are same. Suppose I connected to our ESXi04, and in the another tab, we have a vCenter server. Let's verify the ESX host level settings first. When I select the ESXi host, go to the virtual machine. We have a multiple virtual machines running here. Suppose if I select the same VM, VRA virtual machine, right click the VM, go to the edit settings. When you select the edit settings, we have all the virtual hardware information. Let me increase the font. Okay, when you select the hardware settings within the virtual hardware, just expand the CPU. You can see cores per socket, CPU hot plug, and you can see the resource allocation settings. So CPU reservation, CPU limit, and shares. And the only thing is units per CPU is megahertz or gigahertz. And similarly, if I expand the memory also you can see the memory value. What is the current assigned memory for VRAVM is 42 GB, and reservation we have limit and shares. So reservation limit for the memory, only the difference is we have a megabyte or gigabyte of memory units. Okay, and before going to deep dive into these settings, let's try to verify the same settings in a vCenter level also. When you go to the vCenter server, even in the vCenter server, if you select any virtual machine, for example, I'm selecting a HA proxy VM. Go to the edit settings to the HA proxy VM. Here also we have a same settings. Expand CPU, you can see the same settings. Reservation, limit, shares. And same way, when I expand the memory also, same settings. Okay, hope you understand this point is we can see the same settings for either ESXi host level and vCenter level. But only importance of this feature is if the customer want to reserve the specific memory, suppose this virtual machine, I want to set the reservation. Current reservation is showing as a 0 MB. If you want to set the reservation, you can choose current value 0 MB or minimum also 0, and maximum we can set the reservation is 4 GB because the assigned memory is 4 GB. So reservation also we can set based on the assigned memory maximum. For example, I want to reserve only the 2 GB. Just you can type the memory 2 GB and click on OK. So that means here our virtual machine memory is reserved for 2 GB. So these requirements we are receiving from the customer. So based on the customer requirement, we can set the reservation, and similarly we can set the limit and shares. Okay. So the same point I highlighted in the description here. When available resources capacity doesn't meet the demands of a resource consumer or customer, we might need to customize the amount of resources. So you can customize the resources for reservation as well as limit and shares. But how we are going to edit this information and all, we'll observe in the following slide. Okay, so let's try to understand the differences between share, limit, and reservation. So normally, if you want to power on any virtual machine, a virtual machine power on only if its reservation can be guaranteed. Sorry, if its reservation can be guaranteed, that means in layman terms, if you have enough resources, enough CPU and memory on your ESXi host level or vCenter cluster level, then only we can able to power on the virtual machine. If you do not have enough CPU or memory, we are unable to power on the virtual machine. The same scenario when you are doing practicing the lab in your workstation system. In your workstation, your local system memory is a 16 GB memory. In your workstation, you already assigned the memory to virtual machines, workstation virtual machine. You assigned more than 60 GB of memory. If you assign more than 60 GB of memory, when you are trying to power on the VM, you will receive error message says there is no enough memory. Same case applicable for CPU also. If your local laptop CPUs are quad core processor, 4 CPUs, or octa core processor, 8 CPU processor. If you assign the processor more than 8 CPU, definitely you will get a warning message says that there is no enough resources to power on a virtual machine. Okay, that is a basic funda. And beyond the CPU and memory, configure for a virtual machine, we can apply resource allocation settings to a VM. But when you want to apply resource allocation settings, all should be based on your actual physical resources only to control the amount of resources guaranteed or fixed. So let's try to understand the definition one by one now. Suppose, for example, to calculate all these resources and all, I'm just for our easy understanding, let's consider this as a usage meter. Okay, same like our thermometer, it's a usage meter. Within the usage meter, we can try to understand the concept. Suppose if you want to verify for a CPU, the only difference is the CPU measured in gigahertz and the memory measured in gigabytes. Okay, but the concept for resource allocation, all the concepts is same for both CPU and memory resource settings. Now here, let's say I have a CPU and memory limit that whatever the limit you have, that limit is considered as a available capacity. What is the total available capacity? Let's say my total available capacity in CPU perspective, you can say 100 gigahertz, and memory perspective, you can say 100 GB. But this 100 is like a just approximate value I just mentioned, but these values will change based on our ESXi host capacity. For example, this limit, if you want to see from our vCenter level, log into the vCenter. If you select a ESXi host level, go to the summary tab, you can see the CPU, what is our total capacity. That total available capacity is 11.21 gigahertz. Okay, and same way you can see the memory, our ESXi host one total memory is 16 GB. Same way, if I choose the another ESXi host ESX4, this ESX4 also have CPU total capacity is 9.65 gigahertz. That means approximately 10 gigahertz, and memory also approximately 63.71 GB. That means it's equivalent to 64 GB. So this is our ESXi host level total available CPU limit and total available memory limit. So total available capacity is nothing but this is the maximum limit for our ESXi host. And the same values, when you add our ESXi host to cluster, what is the meaning of cluster? Cluster is grouping of multiple ESX hosts. Whatever the resources we have here, all these resources are added to the cluster. For example, ESX01, if you see below in our CPU ESXi host summary tab, our ESXi host total CPUs are 4 CPUs. And same way ESX2 CPUs are total 4 CPU, and ESX3 is 4 CPUs, and ESX4 is 6 CPUs. That means the first 1, 2, 3 running with your 4 CPU. That means 4 plus 4 plus 4, it's a totally 12 CPUs plus 6 CPUs on ESX4. So 12 plus 4, 12 plus 6, it's equivalent to 18 CPUs. If you go to the cluster, you can see the total processor count is 18. Okay, and same applicable to memory also. Even here we have a memory 16 GB, and ESX2 have a 16 GB of memory, and ESX3 also have a 16 GB memory, and ESX4 have 64 GB of memory. When you add all these resources, it's equivalent to totally 316 means 48, 48 plus 64, it's equivalent to 112, 112 GB of RAM. It's a approximate value it is showing as 111.71 GB. It's approximately 112 GB of memory. So cluster means grouping of all your ESXi host resources. When you group all your ESXi host CPU and memory, we are getting this is the total value, total CPUs 16, 18 CPUs, but the gigahertz, the total capacity is 43.28 gigahertz. And the memory is it's close to 112 GB of memory. So this is the our cluster limit. Okay, but suppose in the real time scenario, company scenario, if you are using a high CPU, high memory of the boxes like 64 GB or more than 64 GB of memory, our cluster available limit also it will increase. Okay, these capacity limits are we have to consider on ESXi host level as well as cluster level. Okay, whatever the physical resources is available, based on your available capacity only, you can apply at the VM level. Okay, so that same point I highlighted here. So available capacity is normally it depends on your either physical ESXi host level or the complete cluster level total CPU or total memory. If you are considering CPU means gigahertz, considering memory means it's a GB. So approximately I just mentioned as a our total GB of memory is 100 GB or CPU is total 100 gigahertz. That is the actual limit. Okay, even if you want to assign your virtual machine more than 100 gigahertz, it won't allow because we don't have that much enough CPU in our physical hardware. Is this point clear? Once you're familiar with the limit, I will go to the shares and reservation. Limit is clear, right? Okay, let's start the another point is reservation. So within our 100 GB or 100 gigahertz of CPU, if you want to reserve certain amount of resources, That is nothing but a reservation. Let's say within our 100 GB of CPU, 100 GB of memory, sorry, 100 GB of memory or 100 GB of gigahertz, I am planning to reserve the 40% of resources. So the units wise 40 gigahertz CPU, 40 GB of memory. That is I am considering as a reserved. Okay, so this reservation value, it's also completely a customer's choice. Whatever the amount of CPU, amount of memory they want to reserve, they can reserve. So whatever the value we reserved, that is considered as a reservation. So when you compare, the limit is 100 GB and the reservation is 40 GB. If you subtract the 100 minus 40, the remaining value is 60 GB. That 60 GB is can be shared value. Okay, so I repeat, the limit is total capacity and reservation is whatever the customer plan to reserve. This value will be customer's choice. In this diagram, I'm just trying to reserve the 40% of resources. Here 100% is limit, 40% is reserved, and the remaining value is considered as a shared resources. Okay, so shares are used to compete in this range. So this shared value approximately 60%. If you're considering CPU, 60 gigahertz CPU, and in the memory perspective, 60 GB of memory is the shared. Okay, so this is the actual differences between share, limit, and reservation. So depends on your cluster total capacity. You can set the limits on your individual virtual machine level, and even reservation also you can set on a individual virtual machine level. Suppose your virtual machine total capacity is 4 GB. If I select any virtual machine, let's say this VM name is, it's a Red Hat OpenShift Container VM 4.10. Within this Red Hat OpenShift Container VM, if I just go to the edit settings, this VM currently assigned CPU is 2 and the memory is 4 GB. Suppose if I expand the memory, the already we assigned memory is 4. The total assigned memory is considered as a limit. So limit, if you want to set to limit or unlimit, means the maximum unlimit is only until the 4 only. Okay, and within this 4 GB, if you want to reserve something, you can just reserve the something. So reserve means 2 GB can be reserved. After reserve the 2 GB, the remaining value is considered as a share. Okay, just a second. Sorry. Okay, so when you see the memory value, the total memory is 4 GB. Within the 4 GB, we reserved the 2 GB, and that limit is already we assigned as unlimited. Unlimited means the maximum limit we can use until 4 GB of memory, and the reservation is 2 GB we assigned. The rest of 4 minus 2, the remaining value is 2 GB. That 2 GB is considered as a share value. Okay, so and before deep dive into the remaining options, just try to understand these three differences first. Okay, later I will explain the remaining options. Okay, so now if you see our diagram, this is the same concept we discussed. Okay, so the limit will be the total available capacity. Within the limit, you can set reservation based on your customer recommendation. The remaining value, the limit minus reservation, whatever the value we have, that value is considered as a shares. Okay, and even in the journal terms, normal any if you consider any other example like flight tickets or train tickets or bus tickets also, even if you want to book your tickets in the movie theater also, there is a normally a seating capacity is considered as a limit. Suppose your flight have a 100 seats, that is the limit for the flight. 100 seats capacity of limit. Within that 100 seats, if you want to book your tickets for your entire family, let's say your entire family, it's like considered as a joint family, you want to book your tickets of 30 tickets. That 30 tickets we have to book, that is considered as a reservation. So within the 100 tickets, you already reserved 30 tickets. Whatever the remaining tickets we have, that 70 tickets is considered as a shared. It can be shared to the other passengers, either it in the flight or train, any of the travel, or even in the movie theater also, same kind of concept. The same scenario, even in the virtualization scenario also, if you want to reserve your resources, and share your resources, the same concept is applicable. Normally, the whatever the available capacity we have in our ESXi host cluster level, the cluster level, the total available capacity is considered as a limit, and within the your total available memory, you can set some reservation. The remaining value is considered as a share. Okay, let's try to understand the definitions also. So limit means a limit specifies an upper bound for CPU or memory that can be allocated to a VM. So example I given as CPU 100 gigahertz and memory is 100 GB. Okay, and reservation. A reservation specifies the guaranteed minimum allocation for a VM. Even if you reserve some certain amount of CPU and memory, that will be guaranteed for us. Okay, and here in this diagram I reserved 40 gigahertz CPU and 40 GB memory, and the remaining value 100 minus 40, the value is 60. 60 is considered as a share. So a share is a value that specifies the relative priority or importance of a virtual machine access to a given resource. That resource can be either virtual machine level you can set, or you can set directly on a cluster level or ESXi host level. Okay, but sometimes if you do not have a vCenter server, you can set the same limits on a direct ESXi host level. Suppose log into ESXi host. Within the ESXi host level also, you can set the same values. CPU, limit, share, reservation. And same way you can set for even other VMs also same options. Expand the memory, you can find the same options. Okay, you can set directly on ESX level, or you can set on a vCenter cluster level. Okay, so that is the point I highlighted here: shares, limits, and reservation. Now let's try to understand some more additional points on shares, because when we say when we edit the any virtual machine edit settings, normally the share only have some additional options: low, normal, high, custom. Four options are available. But when we see the limit and all, it's like a limit is like a current value unlimited we set. That means whatever the memory maximum we have for, that is considered as a unlimited. And minimum also by default they are giving the minimum, and maximum also they are giving. So there is no much option to discuss here. It's a directly straight away options. Even when you see the reservation also, we can reserve the current value is like a whatever you assign, that is the current value, and minimum 0 MB and maximum you can assign based on your total memory. So that these options are pretty straightforward, but when comes to shares, there is some additional options. So these options we are going to discuss now. Let's move on to the next slide. So resource allocation shares overview. So the same option when we right click the virtual machine, edit setting, under the CPU, we have a three types of shares: low, normal, high, and the fourth one is a custom. Custom means you can set any of the value. Okay, and same applicable for memory also. And share refers to the relative or qualified importance of a virtual machine that is on first come first serve basis. Normally, whatever the VM is trying to consume the resources, we already reserved certain amount of CPU and memory on a VM level. Whatever the resources remaining on your ESXi host level or cluster level, the available resources, whatever the remaining available shared resources, it can be assigned to the other virtual machine. It's kind of first come first serve basis. Okay, and share values apply only if an ESXi host experience contention for a resource. Suppose if there is any contention on a VM, then it will start consuming the value from a shared resources. And we can set the shares to a high, normal, low settings, represent the share values with a, this is the common ratio as per VMware. So the ratio for the high is like a, it's a 4, 2 and 1. So high will be 4 and normal means 2 and low means 1 ratio respectively. Okay, and a custom value, there is another option is custom value. The custom value of shares assigns a specific number of shares to a each VM. So these shares can be vary, depends on your existing ESXi host, CPU and memory resources. Let's try to elaborate this point, how we can assign the shares in the real time scenario. See, resource allocation shares scenarios. See, normally the shares is we can assign on a virtual machines are resource consumers. The default resource settings that we assign during the creation work well for most of the machines. Okay, let's talk about the all scenarios one by one. For example, I created a three virtual machines first. When we create a three virtual machine, it started consuming the default share value. The default resource setting is 1000 shares, and VM2 also 1000 shares, and VM3 also 1000 shares. When we see it is consuming a default share values. Let's observe the same option in our virtual machine also. Suppose HA proxy VM, go to the edit settings, we'll see what is the default share value here. When we expand the CPU, you can see the default shares is set to the normal. And when we see the normal means the value is showing as 2000 shares. Suppose if I expand this option, if I change it to low, the share value is changed to 1000. That means it's like a 4 is to 2 is to 1 concept, 4 is to 2 is to 1 ratio. Low means 1000 shares, and if I select normal means 2000 shares. If I change the value to high means it is a high means it's a 4000 shares. It's a default setting by virtual machine resource allocation. Suppose if you don't want to set for your 4000 shares, there is an option for custom also. If you select the custom, you have a facility to modify these custom shares. The maximum share we can set until this value. If you see this value is equivalent to 10 lakh maximum shares we can assign. Okay, so that is a 1 million shares we can assign maximum. But normally in general, it's a by default, it will allocate the resources based on the application and operating system. But until unless your developer team or your application team recommended to set certain share value, then only you can modify these options, or else just leave it as default. And even another easy to understand option is while creation of our vCenter server, or while we are deploying a vRealize automation appliance, we observe the appliances while deploying. There is a multiple sizes of appliances like tiny size, small size, medium size, large size. It's almost kind of a t-shirt sizing virtual machine configuration. Same way in our CPU and memory resources also, there is a different type of sizing. Low means we'll get a 1000 shares. If you set to normal means 2000 shares. If you set to the high means you will get a 4000 share values. And similarly, if you set for a custom, you can modify your share values. Okay, that is the importance of resource allocation shares. The same point I highlighted here. Let's say here it is showing the 1000 shares means it's set to low. Okay, number of shares for three virtual machine set to low. And another scenario is change the number of shares. So we have a facility to change the share value to custom. So custom means the 3000 is not a default value, it's a custom value. So you can modify your shares at any time. Okay, this is a second scenario. And let's verify the third scenario. When you power on a virtual machine, any additional virtual machine, the first scenario and second scenario, we have only three virtual machines here. But in the third scenario, we have a fourth virtual machine is powered on. That means default, it will start consuming a additional 1000 shares from the our ESXi host or cluster level. Okay, this is the third scenario. And let's try to understand the fourth scenario. If the fourth scenario, we have VM1, VM2 and VM4, but VM3 is in a power off state. If the VM is in a power off state, that resources consumption will be blank at the ESXi host level. ESXi host completely resources are free because the VM3 is power off state. When you power on the VM3, again that 1000 shares resource will be start consuming from your ESXi host level. Okay, so that is the importance of resource allocation of shares. Okay, so now we'll try to observe how we can verify this shares information from the cluster level. Let me show you the next slide. So resource allocation settings at cluster level. If you want to see this resource setting at the cluster level, log into the vCenter server, select your cluster. Suppose I am selected the cluster as a production cluster. Go to the monitor tab. Under the monitor tab, there is a separate tab for a resource allocation. When you expand the resource allocation, you can see the resources for CPU, memory, persistent memory, storage, and utilization. So these all the options are available under resource allocation. So when we select the resource allocation, choose the CPU. In the right side, you can find the CPU reservation details. Within this reservation tab, you can see the some additional options. See reservation, what is a reservation? But in our lab system, we haven't set reservation for all our virtual machine, and the limit is set to unlimited, and the type is also few are fixed, few are expandable, and the share value is set to normal. But what type of shares we have? We have high shares, normal shares, low shares, custom shares. But the default all virtual machines set to a normal shares. Okay, this share information you can find from this tab. The same thing we can verify from our lab system. Log into the vCenter, go to the production cluster, and here you can go to the monitor tab. Under monitor tab, you can just look for a resource allocation option. See, this is the resource allocation option. Normally, when you see resource like this, just expand resource allocation. You can see the four options. One is CPU. When we select the CPU, you can see the current CPU, reservation, limit, type, and also the share information. And same way, if you select the memory also, you can find the reservation, limit, and shares. But only difference between memory and CPU is only the units are different. Here is GB, and in the CPU is gigahertz. And persistent memory. Persistent memory is nothing but a permanently assigned memory, or we can say whatever the reserved memory is considered as a persistent. See, you can see the option is reserved. Persistent memory reservation details. But currently we haven't reserved any of the resources. Suppose if I reserved any of the CPU and memory, you will find specifically this option for memory. So if you reserved any memory on virtual machine, that value will be updated here. It will update in a GB level as well as percentage level. Suppose testing purpose, let me choose any one test VM, let's say HA proxy VM. Go to the edit settings. Now I am going to set a reservation here. Expand the memory, and you can already reserve a 2 GB of memory. Just click on OK. So when we click on OK, go to the cluster. Under HA proxy, you can see that some reservation is updated. Let me refresh. Monitor tab, persistent memory. Is memory resource updated? Maybe it's not yet updated. It may require a restart. Once we restart, because it's a Linux VM, once we restart, the value will be updated. So let's quickly restart the VM. You can do restart guest voice. Click on us. In the meantime, we'll verify the other options. Same, select the cluster, monitor tab, resource allocation, CPU. Under the CPU, you can see the multiple options here. The total reserved reservation capacity is 31.81 gigahertz. Cluster total capacity is 43.28 gigahertz. This 43.28 gigahertz is our total CPU value. Okay, and same option available in memory also. You can see cluster total capacity of memory is approximately 112 GB, and the total reservation capacity is 91 GB. But why the reservation capacity is less than the cluster capacity? The meaning is within our cluster, we have a 4 ESXi host. That means all our ESXi host also to run to power on ESX for ESX system also need a some CPU and some memory. So whatever the ESX host memory is used, the remaining memory is considered as a reservation capacity. Okay. For example, if I select the cluster, go to the summary tab, you can see the same one. We have a total capacity is 112 GB. That means 112 GB, and total CPU is 43 gigahertz. This total capacity value only we are seeing from a resource allocation tab. CPU total 43.28 and memory total is 112 GB. But within this 112 GB, we need some memory for a ESXi host also. So after excluding the ESXi host memory, the remaining memory 91 GB only we can assign it to the virtual machines. The assigned total reservation capacity is 91 GB. Within this 91 GB, we already used 57 GB, and the remaining available reservation is 32 GB. Okay, and VCLS is our default vCenter cluster level service VMs. These VMs are lightweight VMs only. These VMs already using 400 MB of memory. The same scenario options are applicable in CPU level also. See, total capacity 43 gigahertz. After excluding the ESXi host CPU, the remaining 31.81 gigahertz we can able to assign to our virtual machines. Okay, this is a virtual machines available capacity limit. Within this limit, we already used this reservation. 7.85 gigahertz is used. What is available reservation? Just my subtract from 31 GB to 32 GB to 8 GB. The remaining is the available reservation. Okay, and this VCLS is our lightweight vCenter cluster VMs. This is using 400 megahertz. It's just less than 1 gigahertz only. Okay, so that is about the CPU and memory. And HA proxy VM is just powered on. We'll verify the is the reservation is still set or not. When we select the memory, the reservation is, oh, it's only 2 MB. Sorry, let's change it to 2 GB. Okay, let's again go to the edit settings, and the reservation is 2048 MB. That means it's equivalent to 2 GB. Now go to the cluster monitor tab and verify the resource allocation tab. Expand resource allocation, go to the persistent memory. If you see here, the persistent value should update. Maybe if it is not updating means just now we did one more modification. It require a restart to update the values here. Okay. The same scenario, you can modify the resources for all the virtual machines. Whatever the reservation you want to reserve depends on the developer's choice or customer's choice. We can set your reservation set both CPU level and memory level. Now let's understand the another concept. But in this scenario, one challenge is, let's say here, if you go to the summary tab, how many virtual machines we have? We have the total virtual machines are 8 virtual machines. We have totally 9 virtual machine, 8 power on VMs and 1 power of VM. Even for 9 virtual machines, if you want to set the reservation limit and all, the manual reservation and shares will be easy job because it's only 9 VMs only, less than 10 virtual machine. But in the real-time scenario, if you have 100 VMs or 1,000 virtual machines or more than 1,000 virtual machine, if you want to set the reservation limit manually for individual virtual machine, it's not a easy job. It's a definitely it's a difficult task. So to address this scenario, we require another solution. That solution is resource pool. Not only this option, even within our vCenter server, let's say if you see here, all our virtual machines are configured directly under the cluster. But if I want to segregate into a systematic way, I want to segregate from a team's perspective, or if you want to segregate test VMs are one resource pool and development VMs one resource pool and production VMs one resource pool. The grouping of multiple ESXi host is cluster, but if you want to group the multiple virtual machines, we require a resource pool to segregate all your CPU and memory resources. Instead of doing a individual virtual machine CPU memory resource allocation changes, you can do directly on a resource pool level. That is the importance of resource pool. Suppose in this diagram, I just for our testing purpose, I created one resource pool. And if you see the summary tab, this is icon for a resource pool. But in the resource pool also, you can see the same as virtual machine resource settings, CPU share, reservation, limit. And same way memory also have the same options, share, reservation, limit. Okay, so this is the settings at a resource pool level. But if I expand the BU I mentioned the name as BU. BU means business unit and RP means resource pool. Within this resource pool, when we create a first resource pool, this is resource pool is considered as a parent resource pool. Okay, under this parent resource pool, if I expand the parent, you can create multiple child resource pools here. Suppose select the BU resource pool in the right side. If you go to the resource pool tab, I created within the business unit, I'm creating a multiple resource pool. And this names and all you can configure depends on your company structure. Okay, suppose your organization have different departments. Based on your organization departments, you can configure a resource pools. Suppose the business unit resource pool consists of 4 child resource pools. One resource pool is IT operations team, and one resource pool is IT developer team, and one resource pool is HR team. Another one is finance team. Okay, these all resource pool also have again the same settings: CPU reservation, CPU limit, CPU allocation, CPU shares. Whatever the units we have a features for CPU, the same features available for memory also. Okay, that is called business resource pool is a parent resource pool, and the remaining under BU, whatever the resource pool you created, all this resource pool is considered as a child resource pool. Okay, not only one resource pool, you can configure multiple resource pool. Suppose I created another resource pool called infra management resource pool. Under infra management resource pool, I configured the multiple resource pool based on our company team structure. Like suppose I have a team for virtualization team. Virtualization team means our VMware team only. All our VMware team related virtual machines I configure directly under this resource pool. Okay, and all our technical support team VMs I configured under this resource pool. How we can configure is just right click the VM, you can create virtual machine. Okay, but the before creating the VM, we have to reserve the certain amount of CPU and memory on a resource pool level also. Whatever we observe the options on VM edit settings, the same options available on a resource pool level. But only difference is instead of doing on a individual virtual machine level resource settings, you can directly allocate the resource settings directly on a resource pool level. Even if you understand the name resource pool, pool means it's a kind of grouping of multiple virtual machine resources. Okay, that is the benefit of resource pool. This resource pool is even workload resource pool also I created. This all I created for testing purpose. If you want to remove, I just remove, and I will show you again how we can create this resource pool. Right click and delete. Delete is just a straight away procedure. Select the infra management resource pool, delete. All the child also will delete automatically. And same way workload resource pool, just right click and delete. Okay, so now I will show you how to create the resource pool one by one. Before creating the resource pool, let's try to understand the concept of why we use resource pools. Okay, let's move on to the next slide. Virtual infrastructure, one of the challenge and what is the solution? Or some scenarios we may get the question like why use resource pool, or we can say why we use resource pools. The challenge here is the customer may have some challenges. I highlighted only 3 challenges here. So first challenge is how to do separation of resources from ESXi host hardware level. So ESXi host hardware level, that means let's try to elaborate this question first. Suppose if you see that I highlighted 3 scenarios here. Normally every organization have some business units, kind of departments. Here I highlighted here 4 departments within the organization. Every organization finance team is common, and human resource team, HR team also common, and IT operations team also common. Operations team means our technical consultants, system administrators, system engineers will work under the IT operations team, and the developers who is doing the automation coding and all, they will work under the IT developer team. So these 4 teams are normally it's common, but the team name slightly will vary from company to company. But the normally the team structure is looks like this only. Suppose let's say within the business units within the organization we have a 4 departments. These 4 departments they invested some amount for the buying a hardware. Let's say finance team invested approximately $1 million for one high configuration of ESX box, and HR team also invested $1 million for one high configuration ESXi host hardware. You may ask why HR team need a ESX box. Even HR also using some application, payroll related applications, and they in order to run their application they need some virtual machines to run the HR portal, and even our personal employee account portals and all. It will run on a backend some of the virtual machines only. So HR team also need some VMs, and IT operations team also need a VM, especially the Active Directory VM and the DNS, DHCP, file server, backup server, any of the security team VMs. These all comes under the IT operation team, and any application, web server, database server, SharePoint server, development, coding related applications, all are comes under the development team. So they invested $1 million for one box, and even IT ops invested for $1 million for one server, one high configuration of ESX box. You can buy either HPE box or any other vendor servers, but these 4 servers they purchased. But their intention is even finance team they are expecting us for after buying that one ESX box, they want to get the all the features like vSphere features, high availability, DRS, they want to use within one ESX. But when they have one ESX box, if you want to utilize all the resources with high availability and also the DRS feature, it's not possible, because if you want to create a cluster in our vCenter server, the minimum requirement is 2 ESXi host, recommended is minimum 3 ESXi host, and you can create maximum 96 ESXi host on our vCenter cluster level. But here in our scenario, we have a 4 ESXi host. Individually, every team purchase they procure one ESX box. But if they want to get all this high availability load balancing features, what is the solution? We have to create a cluster. Under the cluster, you can add 4 ESXi host. Okay, but ESXi host money, ESX1 money is dedicated to our finance team. ESX2 money is dedicated to HR team, but ESX3 money is dedicated to other IT ops team, and 4 is for IT developer team. But how we can segregate these resources at the cluster level? But when we add this ESXi host cluster, all resources are combined into a one root resource pool. Even cluster, we can also call it as a root resource pool. This cluster consists of all the ESXi host CPU and memory. But if you want to segregate their individual ESXi host to CPU and memory, the only option is when you right click the cluster, we have a facility to create a resource pool. Okay, using resource pool based on their hardware max limit, you can set their actual limit here. Okay, whatever their purchased ESX host CPU uh, total capacity, that value you can set here. And same way, suppose their ESX host total memory is 90 GB, you can set their memory 90 GB is here. Okay, but these values, we have to understand the logic of the concept, but the values and all will vary from depends on your ESXi host hardware configuration. Okay, but the concept is simple. Why we are using resource pool is, if you want to separate your hardware resources, we do not have a direct option in the cluster level. We need to use another cluster feature to segregate your hardware resources, that is called using resource pool concept. Okay, but even remember that this resource pool we can create only on a vCenter cluster level. Even if you want to create on a data center level, there is no option to create a resource pool here. Even if you want to create resource pool on a single ESXi host, let's log into our single ESXi host. Right click the ESXi host, there is no option for resource pool. Okay, this resource pool concept will comes only on a vCenter cluster level only. Okay, that is the important point. Okay, so to segregate the separation means it's nothing but a segregation. To segregate your ESXi host hardware, the only concept is we have to go with a resource pool. So that is the reason I mentioned the solution is resource pools are the solution for these challenges. Okay, but in this scenario for 4 departments, we need to create a 4 resource pool. One resource pool for a finance team, one resource pool HR, and similarly other teams. Okay, and let's try to understand the second challenge. Second challenge is how to isolate, even isolate also nothing but a separate only, how to isolate the VMs among the business units. Even if you want to separate the not only hardware, you want to separate your virtual machines also, the solution is creating of virtual machine. For example, if you log into vCenter, see, we have a 9 virtual machine, 336 and 3 VCLS VMs. The VCLS are the lightweight VMs. Okay, if you go to the VMs tab, you can see VCLS VMs. Okay, this VCLS VM we can safely ignore. But even if you see the remaining 6 VMs also, these 6 VMs, there is no segregation here. All are configured directly under the cluster. Suppose I want to segregate all my VRA VMs under one cluster. Before deep dive into the concept, I'm just quickly showing you how to create a resource pool. Let's say I'm creating a resource pool, this resource pool for my automation team. So I'm just mentioned as a automation team. These names you can keep the name based on your convenience. I'm just mentioning the resource pool name as automation. That means this automation resource pool planning to keep all my automation VMs under this resource pool. But the resource values I haven't modified yet. We can modify it later also. So resource pool is created. When you create the resource pool, the CPU, VMs, and everything is showing as blank. Okay, but what is the free capacity is showing? This free capacity and all based on your cluster available CPU memory values only here. Okay, and the allocation wise it is showing as 0, but the share values are defaultly set for a normal. Okay, but if you want to move your virtual machine to this resource pool, we can migrate in a two ways. Just select the virtual machine. For example, our identity manager VM, VIDM VM. You can just drag and drop it here. When you drop it here, this resource pool is running with one virtual machine now. Okay. Same way, if you want to move our VRA VM, VRA VM, vRealize Automation VM, just right click the virtual machine. You can choose the option either move to folder or move to resource pool. You can, while moving only, you can choose that is one method, or else simply drag and drop it here. It's moved to the automation resource pool. Same way LCM VM also comes under the automation VM only. So under the automation, we segregated three VMs. The remaining two are the, if you see here, it's a Red Hat container VM, OpenShift container VM, and HA proxy also related to the, this one I plan to create for a tangible purpose. Okay, so that resource pool, if you want to segregate again, create one more resource pool. Let's set the name, any of the customization name, suppose containerization. Okay, or you can say Kubernetes, enterprise Kubernetes. Kubernetes short form I'm keeping as KATES. Okay, enterprise Kubernetes, one resource pool I created. Under the enterprise Kubernetes, I'm moving a HA proxy. Normally HA proxy we used for a load balancing purpose. It's a open source free tool only. This is one of the appliance VM only. Okay, I download from VMware site. And another one is Red Hat OpenShift container VM. You can just drag and drop it under enterprise. These two are the all enterprise container VMs I'm planning to configure under a enterprise Kubernetes cluster resource pool. Same way, if you want to create a test VM, let's say right click here, you can create a resource pool and set the name for test resource pool. All your test VMs you can configure here. And the names you can, based on your convenience, you can keep. Let's say for easy understanding, I mention as test RP. RP means resource pool. So under test RP, you can just move this deployed VM, test VM to test RP. Okay. See, now we have a complete segregation for all your virtual machines. And for easy understanding, you can rename automation hyphen RP01. Suppose in future, if you are creating multiple resource pool, we can increase the number RP01, and here also right click and rename RP01. This is the first resource pool within the enterprise Kubernetes. Even test resource pool also, if you want rename, you can just rename 01. Okay, so like this we can create a resource pool, and we can also move the virtual machines under the resource pool. The same point we highlighted here, how to isolate the VMs among the business unit VMs, other category VMs. Other category means these categories and all, just for our easy understanding I given the category name and all, it's completely a customer's choice. Okay, but we understand that how to create a resource pool based on our convenience and segregating the virtual machines under the resource pool. So this second point is clear. This challenge, if you want to address this challenge, the solution is resource pool. And same way, the third point is how to set share reservation limit to n number of virtual machines. Suppose your all n number means you can keep any number, either 100 VMs or more than 100 VMs, 1000 VMs also. If you want to set the shares reservation and limit, individual virtual machines is not a easy task, it's a difficult task. So to automate that one, the best option is you can set your share reservation under the resource pool level. See, if you select the automation resource pool, right click here, we have an option for edit resource settings. When you select the edit resource settings, we have an option to set your shares either normal, high, low, and custom, and even the reservation also. If you want to reserve certain amount, they given maximum reservation is until this value. Okay, and even the reservation type, there is another option is expandable. If we select this option expandable means this reservation can consume until your limit. Okay, suppose if you uncheck this option, the reservation is dedicated until the maximum value only. Okay, the same scenario applicable for memory also. But whatever the settings we assigned at the resource pool level, these settings are applicable to all your virtual machines. Okay, so even in the summary tab, you can see the same option: CPU settings and memory resource settings. Okay, and see that examples are given here. What is the departments and what is infrastructure team? Normally in the IT infrastructure management team, in real time scenario, we have this many teams. Like virtualization team means our VMware team, network team means they will taking care of all the network devices, storage and backup team, they will take care of storage devices and taking the daily backups of our virtual machines, and monitoring team and tools team, they will help us to do the monitoring of all our IT infrastructure. And automation team, they will use some automation tools like vRealize automation or any of the infrastructure as a code softwares like Ansible, Terraform and all automation tools they will use. Okay, and security operations team, they will do a vulnerability scanning and also any of the ransomware protection tools they will use. Okay, like this we have a IT infrastructure teams. If you want to segregate all your individual team VMs also, the only option is we can create resource pool, and under the parent resource pool you can create multiple child resource pool. For example, within the automation resource pool, we have a 3 virtual machines. Okay, but in the resource pool tab there is no child resource pool. If you want to create a child resource pool also, right click this resource pool and there is option to new resource pool. Okay, so under the automation, I'm just putting the tool is like a code automation. So because like there is a coding team also, let's say we keep the resource pool name as a code RP01. This is dedicated for a coding team. So this is like this we can create a child resource pool. Okay, not only one, even you can create multiple child resource pool. Under the automation, I want to create a separate team for dashboard team. Even there is a separate team to maintain a all your company dashboards. Okay, so let's say I mention as a dashboard RP01. Dashboards means they will use some third party tools like they will use a Tableau or any of the softwares, external softwares they can use to prepare a dashboards. So the dashboard team also will create it under a automation team. And similarly, if you want to configure another child resource pool under the containers, let's say under enterprise Kubernetes, I want to segregate like a one team for a VMware Tanzu resource pool. So I mentioned the child resource pool name is Tanzu RP01, and another resource pool is I'm planning to another child is dedicated for a Red Hat. Even Red Hat also have a containerization software. That software name is OpenShift Container Platform. In short form OCP. Let's say OCP RP01. So Red Hat container VMs we can configure under the this one. Red Hat also have a enterprise Kubernetes software. Suppose these two VMs, if I want to move HA proxy under the HA proxy is related to Tanzu. So just move it under Tanzu child resource pool, and even Red Hat also related to Red Hat, just move it under Red Hat child resource pool. So like this, we can move the resources under the child resource pool also. So that means now here the hierarchy is our main cluster is considered as a root resource pool. Under the root resource pool, our parent resource pools are, we have a 3 parent resource pools: automation, enterprise, test. But for automation and enterprise, the relation is like a sibling relationship, but the automation is a parent resource pool. Under the parent resource pool, we can create a multiple child resource pool. Okay, same way under the enterprise parent resource pool, we can create a 2 child resource pool. One is for Red Hat container platform, another one for VMware container platform. Okay, so like this we can configure. Even under the test resource pool, you can configure a multiple test child resource pools. Okay, the same concept I highlighted here. Okay, how we can set the reservation? You can set the reservations on a either parent level, child level, and again you can create a multiple child resource pool, depends on your organization structure and teams. And similarly, infra workload and developer teams also, there will be a multiple teams like application team, web developers team, SharePoint team, database team. So each team also we can configure a separate resource pools. Okay, to address all these challenges, the common solution is resource pool are the solution for these challenges. Okay, now let's try to understand the resource pool architecture. So resource pool architecture means a resource pool is a logical abstraction, or we can say logical construct of hierarchy. Hierarchy means orderly managed CPU and memory resources. That is the definition for resource pool. Okay, but within the resource pool, the looks like the structure is like this architecture. The cluster is CL means cluster one is considered as a root resource pool. Under the cluster, you can configure multiple resource pools. These resource pools, if we have here, there is a one marketing resource pool, one QA resource pool. These names and all we can modify any name. So here it is a one is marketing resource pool, another is a QA. QA means it's a quality assistance, QA testing kind of resource pool. This QA resource pool and marketing both are considered as a sibling resource pools. Okay, and under the RP, whenever you create a sub resource pool, that is considered as a child resource pool. Okay, for this child, RP is considered as a parent resource pool. This is the resource pools architecture. Okay, so this names and all we can configure anything. And this diagram I just captured from VMware website. Okay, it's a standard structure from the VMware also. Even if you see the domain is vmware.com. Okay, so let's try to observe the same architecture in our lab scenario. Even in our lab scenario, I created like this, identify the resource pool hierarchy. Suppose here prod cluster 01 is considered as a parent resource pool or root resource pool. This prod cluster 01 is considered as a parent resource pool or root resource pool. What we can say this one?
Parent resource.
This prod cluster 01 we can consider as a root resource pool. Okay, because cluster is always root only. So here our prod cluster is considered as a root resource pool. Suppose BURP is considered as a parent resource pool. Under BU resource pool, we created a some sub resource pools. These all considered as a child resource pools. Okay, and infra management. Infra management also if there is any child resource pool, this is considered as a parent resource pool, and relation between BU and infra is like a both are a sibling resource pools. Same like our this diagram. Okay, this two resource pools are sibling and cluster is root, and whatever the child we have, that resource pool is also considered as a parent resource pool. Okay, the same thing we can verify in our lab also. Our lab also we created a three sibling resource pools. Within the automation parent resource pool, we configured a two child resource pools. Okay, and same way under enterprise Kubernetes resource pool, we created a two child resource pools. Even if you expand here, you can see the structure is like this: parent, two childs. If you expand here, parent, two childs. Okay, so same point I highlighted here. Now let's verify the resource pool attributes. So whatever the features we discussed in earlier virtual machine edit settings, the same CPU share reservation limit are applicable in a resource pool level also. So attributes is also call it as features. We can create a child resource pool of any ESXi host resource pool or vSphere DRS cluster. So this child resource pool can be created on ESXi host. That means within the cluster ESX host, not in a direct ESX host. Okay, and shares are like a we can configure the shares low, normal, high, custom. So same options we can configure. Even if you want to configure as a low means the values will be changed, same like our previous scenario. If I select the low, the share value is 2000. If I select the normal, share value change to 4000, and high means 8000. That means the value is always 4 is to 2 is to 1 ratio only. Suppose if you want to customize this value, we can choose custom. Okay, so this resource reservation and all, always it's our choice to set the values. Even if I just cancel, just right click the enterprise resource pool, go to edit setting, the default is set to normal. Okay, but we have a facility to modify. And reservations, even reservation also, whatever the amount you want to reserve for CPU and memory, we can reserve. Okay, it is also our choice only. There is no restriction how much you want to reserve, but the reservation always depends on your total limit. Within the limit only we can reserve. Suppose your memory is 100 GB, we can reserve until 100 GB only we can reserve. Maximum reservation is 100 GB. Normally the companies they may reserve 40 GB, 50 GB, 60 GB. Okay, and whatever the remaining free space, free memory is considered as a share only. Okay, and limit, even limit also, actual total capacity is considered as a limit. And unlimited access is the by default option. Even if you create our new resource pool also, right click edit settings, if you see limit by default is unlimited. That unlimited point is mentioned here, unlimited access by default up to maximum amount of resource accessible. Okay, and the reservation type, we have a one additional option. This option is available in a resource pool edit settings. Resource reservation type is, there is a option for expandable, you can check or uncheck. Suppose expandable option is selected, that means virtual machine and the sub pools can draw from this pool's parent. That means child resource pool, it will pull the resources from parent resource pool. Even parent resource pool, there is no enough resources, it will pull the resources from a root resource pool. Okay, and the same way if it is deselected, that means unchecked this option, that means virtual machine and sub pools can draw only resource from this child pool or parent pool only. It won't draw the resources pool from a parent. Okay, that is the importance of this expandable option. Okay, so we understand the resource pool features also. Now we'll talk about the resource pool use cases. Normally in which scenarios we'll use means, whatever the scenario challenges we discussed, to address those challenges only use cases. So flexible hierarchy organization. So hierarchy, see if you see here, earlier all the VMs are in a directly under cluster, but now we maintaining a proper structure. We segregated the VMs, automation VMs to automation resource pool, and Kubernetes VMs to Kubernetes resource pool, and test VMs under test resource pool. So that is nothing but a flexible hierarchy organization. So flexible means the names and all you can keep based on your convenience. And also isolation between pools and sharing in pools. Even you can share that pools to the multiple virtual machines. And access control and delegation. Even if you want to provide a permissions to this resource pool also, select the resource pool. Right side there is a tab for permissions tab. If you want to modify the any permissions and all, we have a facility to add the permission and modify permissions. Okay, but present in our vCenter, we are using the administrator credential, but in the real-time scenario, if you have any of your specific employee or application team accounts, those accounts you can add the permissions. In general, automation team will have permission on automation resource pool, and Kubernetes team will have a access on a Kubernetes resource pool, and testing team will have access on test resource pool. Okay, the permissions we can assign from, select the resource pool, actions tab, and you can choose the add permission. Okay, that is a point, one of the use case. And the separation of resources from hardware separation also we can assign. And the management of sets of virtual machine running multi-tier service. Multi-tier means within the test VMs, if you want to set the tiers like web app DB child resource pools, we have a facility to set. And the ability to prioritize virtual machine workload, we can also prioritize the all the virtual machines workloads. And we'll observe the one example for resource pool scenario. Let's say this example shows where resources features are set on a resource pool. Suppose we have a multiple hardware is available in our data center. Within the hardware, we are trying to observe the engineering resource pool. This engineering resource pool, we set the CPU is 4000 shares, reservation 1000 megahertz, limit also 4000. That means the maximum limit is 4000 only, and expandable reservation set to yes. This is the option we set at a parent resource pool level. But how it will be assigned to a test VM and production VM. For test VM by default reservation set to 0, and production VM there is a some reservation, it will get automatically from the resource pool. And the CPU shares it will be assigned as a 1000, and for a production VM it will consume a some additional shares. Okay, and limit is always limit based on your parent resource pool limit only. Okay, so this is the example how the limit will set automatically. We no need to modify based on your existing host capacity values. Our only modification we can do at a share level and reservation level, and limit and all based on your ESXi host or cluster's total capacity. Okay, but sometimes if your organization will give you instructions how much limit we can set. Okay, but in our lab we are just using a unlimited reservation and unlimited limit. Okay, this is the concept of resource pool. So for example, if we log into the resource pool, uh, select the vRelays resource pool. Under the vRelays automation resource pool, we have a three virtual machines. Instead of setting the resource settings under individual VM, we are directly setting the resource options on a resource pool level. That is the importance of resource pool. But there is some additional advanced features. If you want to do all these VMs, I want to restart one by one. But if you want to do restart one by one means first right click one VM or go to the power option, we can restart first the VIDM VM and then you can restart a VRA and then we can restart a LCM. This is a if you have three virtual machine, it's easy to do manual restart. Suppose if you have a 10 group of automation VMs. For this 10 VMs, we have to wait every time one virtual machine is powered on and we need to wait and again restart manually. So 10 virtual machine restart may take roughly 30 to 1 hour time. So 30 minutes to 60 minutes time. So, but in order to avoid your manual task, there is a one advanced feature in resource pool. Resource pool advanced concept is vApp. If you want to create a vApp, even vApp also available only under the cluster level. So just right click the cluster, you can see the option to create a vApp. So when you select the vApp, the purpose of vApp is it will help you to do power on, power off operations on your group of virtual machines. So even the whatever the features we discussed in the resource pool, the same features available in vApp also. But apart from resource pool features, within our vApp, we have additional features. You can do the virtual machine startup and shutdown sequence properly. If you want to restart the virtual machine within the sequence, that sequence options you can set only in a vApp level. The rest of the concept is same like resource pool. So before going to the lab, we'll quickly discuss the concept. See, managing the VMs with a vApp. So vApp creation is just now as we observe, right click the cluster, we can create a new vApp. While creation of new vApp, we have a two options. Either you can create a new vApp or you can clone the existing vApp. With the two options are available. So when we create a new vApp, all your virtual machine CPU and memory resources become a part of the vApp. So a vApp is an object in the vCenter server inventory. This feature is not available on a single ESXi host. It's this feature available only on a vCenter cluster level. And a vApp is a container for one or more virtual machines. You can add either one VM to vApp or you can add multiple virtual machine to vApp. And a vApp can be used to package and manage multi-tiered applications. Multi-tiered application means like web tier, app tier, DB tier, database tier, all these tiered applications. The best way is we can add under vApp. It will take care of automatic reboot sequence. Okay, that is the benefit of vApp. Let's verify the vApp features. So vApp characteristics, or we can also call it as features. The vApp characteristics involves like a, we can configure several vApp settings by right clicking the vApp. When you right click the vApp, we have multiple options. So those options involve CPU and memory allocation. This is almost same like a resource pool. And apart from this option, there is a one additional advanced option is IP allocation policy is available in a vApp. And we can also configure the virtual machine startup and shutdown order. This option only available in vApp. This is also one of the interview question. Let's say customer may ask not only CPU memory resource allocation, I want to plan to restart the group of virtual machines startup and shutdown order. Which is the vSphere feature I can use? So to address this scenario, the only feature is vApp feature. So using vApp feature, we can able to configure the group of virtual machine can do within a startup and shutdown in a sequence. Okay, I will show you how we can set the sequence. And another feature of vApp is exporting the vApp as an OVF format or OVA format, open virtual format or open virtual appliance format. Okay, and then once you export that OVF format, that vApp can be shared with other team members or other customers and used for a archival purposes. Even if you want to take the backup of vApp also, you can take the backup. These are the two additional options in a vApp. Okay, now let's verify the lab one by one. So create resource pool, we verified how to create resource pool, we know, and setting the resource pool features like CPU share reservation limit, we verified, and child resource pool creation also we verified, and resource allocation settings at cluster level also we verified. How we can verify in the cluster level is just select the cluster, go to the monitor, under the resource allocation you can verify the values. Okay, and even same way storage also you can verify here what is the storage reservation and all. And next option is create a vApp. I will show you how to create a vApp. So right click the virtual machine cluster, you can choose vApp, but before creating the vApp, just for our testing purpose, let's try to move our VRA VMs to out of the resource pool. Just drag and drop to the cluster, drag and drop it under cluster. So this resource pool, automation resource pool. Now, if you go to summary tab, there is no virtual machine, but only have two child resource pool. But these VMs are running directly under the cluster. For our testing purpose, this automation VMs, I'm planning to add it to our new vApp. Okay, so let's observe the how to create a vApp. Right click the cluster, you can choose new vApp. So we are planning to create a new vApp. This option guides you through the creating a new app. You will be able to customize CPU and memory resources. Click on next. See here, it is asking us to set the vApp name. Let's say I'm sending one vApp name is vApp01, or you can keep any of the customization name also. Let's say this vApp is mainly for VRA purpose. So I mentioned as a VRA vApp01. And VMs also, if you want to configure the VRA VMs, just select this folder, click on next, excuse me, click on next, and resource allocation. This resource allocation, same like our resource pool settings, CPU share we have default normal and reservation is default set to 0, but reservation type is expandable option and limit is unlimited. And same way for memory option. Click on next. And we can see the our name is VRA vApp01 vApp name, and the location VRA VMs production cluster 1 it is going to create, and allocation is we set it as a unlimited CPU, unlimited memory. So now click on finish. So when we create the vApp, you can see select the vApp. You can see the icon like this. Go to the summary tab. This is the icon. But currently the usage is completely 0. That means there is no virtual machines. If you want to add the virtual machine, just right click the vApp. You can create new virtual machines manually. That is one method. Or else if there is any existing VMs, just drag and drop it here. And same way, drag the another VM, drop it here, and same way LCM VM, drag and drop it here. So when I select the VRA vApp, under this VRA vApp, go to the VMs tab, you can see 3 virtual machines running here. Okay, and vApps, there is no sub vApps. Even if you want to create a sub vApps also, we have a facility to create a sub vApp, means it's nothing but a child vApp we can create. Okay, so now we have a 3 virtual machines. Let's try to observe what is the additional features in a vApp. Right click the vApp, go to the edit settings. When you go to the edit settings, the resource tab we are familiar. The resource tab is same like a resource pool settings, but there is additional tabs are available. One is start order. See start order, if you want to set the order, we can set the start order here. For example, I want to start the order with a first order is VIDM1. Okay, this is the first order. And then this is already it's set to the order group 1 and group 2. Even if you want to modify these group orders also, we can use the modification 3 to 1, or you can modify like a 1 to 3. These orders we can modify anytime. So currently default it's set as a whatever the VM's adding procedure, how we added, same way it's automatically selected the order. So even in the real-time scenario also, if you want to restart a vRealize automation, the restart procedure is first we have to restart the identity manager and then vRealize automation and finally lifecycle manager. This is the sequence. So when you select this sequence, okay, this is grouped by one, and even these options, power on option, power off option, shutdown and startup are automatically set, and the delay is 120 seconds. 120 seconds means it's almost close to 2 minutes. Now click on OK. This is the start order. And same way IP allocation, even if you want to set the any IP allocation 4 and IP allocation 6, anything we can set. But currently we are not going to set the IP allocation here. But normally some of the OVF file, if you want to set in your environment IP allocation using vApp, we have a facility. Okay, and go to the details tab. Even if you want set the product name, any application related product name and all, we can set the vendor URLs, all the details under the details tab. Okay, but I'm not going to set this options at present. Just selecting the start order, click on OK. So when you click on OK, the VRA vApp also power on state and the VMs also in a sequence manner. But if you want to do the start and stop of these VMs, you no need to go to the individual VM and all. You can just right click the vApp and here go to the power. We have an option to power off, suspend, shutdown. Okay. Suppose if I want to shutdown option, first option as per our sequence, it will shut down the IDM first and then it will shut down the remaining VMs. So we'll test these options. Right click the VM, go to the shutdown. So shut down the selected vApp, click on S. When we click on S in the recent task, if you verify, it will trying to shut down. The first shutdown will be IDM VM, and after the IDM VRA, and then sequence will be LCM. Go to the monitor tab, tasks, we can see the sequence here. Okay, even if you see the time, we can see the timings here, the sequence of timings. Okay, so that is how we can do the vApp startup. And even if you want to start up also, just go to the power, turn on. When you select the power on, it will automatically power on the first VM IDM, and then it will power on the our VRA VM, finally LCM VM. So power on will be also power on automatically as per the sequence. See, start vApp is in progress. It's trying to power on the IDM first. Once the IDM is up, it will trying to power on the VRA and finally LCM VM. Okay, so it may, because we realize automation VM, it may take some time to boot up. Okay, so we verified the create vApp and power on vApp, and the last option is remove a vApp. If you want to remove the vApp also, it's just a simple right click the vApp. There is option to remove from inventory or delete from disk, but currently it's in a power on state. That's why these options are grayed out. Okay, and removal option is pretty simple. Even the resource pool removal also very simple. Right click the resource pool, delete. Okay, and suppose if there is any running virtual machines on the resource pool, it won't recommend to delete immediately. We can migrate the VMs to directly under cluster and then remove the resource pool. Same way for vApp also. If there are any power on virtual machine, it won't allow you to delete the vApp directly. Okay, so we observe all these 7 labs. Okay, so that's it for today. Let's update our master checklist. Let's say in our previous session, we covered the, I think we updated already the content library, and today's session we covered resource pool concept and vApps. Okay, so next session we can cover the remaining vSphere features. Okay, so if you have any questions, let me know.
Thank
Yeah, if no questions, yeah, thank you. That's it for today. Thanks for your time. Thank you. Bye for now.